Okay, good morning, everyone. Thank you very much for coming today, for having me here today, and thank you very much for the nice introduction before. So yesterday, you saw a lot of interesting data. Today, you will hear some philosophy somewhat, I guess. So I will talk about phenomenology-first approaches and category theory. So if you're interested in the topic, I think there are two ways to do it, and one way is the wrong way to do it, and the second way is the not wrong way to do it, and I will present obviously about the not wrong way to do it. But before I start to give you some details. So anyway, why now is perfect. Thanks. So before I will start to give you an outline of what I will talk today, I will do some introduction first, and I think most of us are kind of okay. Most of us, or most of you, probably know that in principle, but it often doesn't get mentioned enough, in my opinion, in consciousness science, and people forget about it. So that's why it's good to stress it. Studying consciousness is very different from doing anything else in science. So you can, I don't know, think about molecular motion or the origin of life or whatever you want to do. But consciousness is really different. And people often people often forget that it's very different. And the difference is this, in my opinion, studying consciousness essentially involves what people call a first-person perspective. So something it is like to have or to experience compared to what we usually do in science, which is just studying things from a third-person perspective. So that's a very fundamental point, and it doesn't relate to, I mean, there's no bearing on whether you think that can be reduced or cannot be reduced or whatever. You just have these two perspectives and you need to reconcile it, however you do it. And that's for any approach, that's probably true. Now, I must say at this point that I think that a third-person perspective doesn't exist and first-person data do not exist. So that's a bit complicated, but I will spare you that for a moment. So roughly, at least, you can say, okay, you have these two perspectives and you need to relate them, how to do it. And there's a conventional approach, which most people in the field are actually trying. Mostly a reductionist approach. We start with third-person data, and then we somehow try to construct what people call the science of consciousness. And people are doing that and have been doing that for many, many years, but so far it's failed. So there is no good, really satisfying theory of or science of consciousness at the moment. We're still in a kind of early phase of this research. So I have a picture here, if you can recognize that. A lot of people used to liken the situation in the study of consciousness with what people do, what chemists did with water. They said, okay, water is something like an emergent property for molecules, and the same should be true about consciousness. Well, there's a big problem here. It doesn't respect this whole third-person thing, which I was just talking about. That's why I would still subsume it on a reductionist approach. There is a bit more technical, philosophical discussion here, the different senses of emergence and different senses of reductionism and so on and so on. We can obviously go into that, but it's probably not so interesting for you. More interesting is what I think is the better option, is actually starting with the first-person perspective and then specify or see how it relates to third-person data. And that's what I will talk about today. Now, in order to do it, one has to start somewhere. And for today, I have two starting points, which I want to talk about. On the one hand, phenomenology, philosophical phenomenology. You see here a picture of Edmund Husserl. He's widely regarded as a kind of founding figure in phenomenology. If you want to give that a definition, one would say, okay, phenomenology, or a definition which you often hear, which is a bit wrong, but still often hear it, engaging in systematic study of the first-person perspective. You see here on the slide, there's an asterisk. Whenever you see on my slide some statement with an asterisk, it means it's not entirely correct, actually. You have to finesse it a bit. But as a first pass, it's okay. So the systematic study of the first person perspective. I will, in a few minutes, I will tell you what I think how one should finesse. Anyway, but before, so to say, as an introduction, it's good to become clear on certain distinctions which you could draw or should draw. So the first distinction, and that's something which is often conflated, is the distinction between phenomenology, philosophical phenomenology, the systematic study of the first person perspective, and phenomenology, which is related to introspection. So when we think about consciousness, how is consciousness given to us in introspection? That's an interesting question. It's not quite the same as philosophical phenomenology, which is a bit more systematic and methodological. And it has certain kind of, well, certain subtleties, which you often do not have. So phenomenologists are always very keen to say, oh, what we're doing is not just introspection, we're doing something else. Of course, then it's a question, what is this something else? Show me. It's not always so easy, but at least one should keep it in mind that depending on the method of a phenomenologist you would choose, it's not the same as just introspection. Okay, next distinction. So even if you buy into the first distinction, if you look at the literature in phenomenology, it's huge, and there are many subfields of phenomenology. And usually, most subfields are associated with one of the famous figures in phenomenology. And one of the very unfortunate things in phenomenology is that there's no kind of school or hardly kind of a more streamlined methodological approach. Most phenomenologists, once they got famous, they kind of produced their own methods. So for example, I talked a bit about Husserl. Husserl's most famous student is Martin Heidegger. Martin Heidegger said basically, oh, okay, Husserl's methodology, forget it. You're doing something completely different. And that's a bit of a problem, because if you want to have a scientific discipline which has some historical continuity, then it's maybe not the best thing to get so iconoclastic. Okay, so what's the kind of type of phenomenology which I subscribe to, or which I will talk about today? So I just listed some examples. Descriptive phenomenology, which is just trying to describe whatever is happening in your experience. A variety which I like, transcendental phenomenology, that goes back to a notion, transcendental philosophy, a notion which you might know from Immanuel Kant. It's about finding the conditions of possibility to make certain experiences. I will later revisit that. Hermeneutic phenomenology is another kind of sub-branch of phenomenology, which is about understanding and getting to grips with either historical or individual ways how you experience it. Okay, and the third point, and it's a methodological point, I'm very interested in mathematized phenomenology. Not phenomenology of mathematics, but mathematized phenomenology. That means trying to apply mathematics or use mathematical tools to translate or to render or make intelligible those phenomenological ideas. So it's not something in the philosophy of mathematics where you think, oh, what's the nature of mathematical entities? I think that's interesting, but that's not what I will talk about today. I'm talking about mathematics phenomenology. So that's the, so to say, first pillar of what I will talk today. The second pillar is, you might have guessed, about category theory. It seems to be a kind of intricate or maybe an obvious link between phenomenology and category theory, in a sense that both phenomenology as well as category theory are heavily about relations. Phenomenology, for example, you have, depending on what kind of texts you're studying, you have two kinds of relations which are important. One is what I call a modal structure, which is the way how experience relates to possible other forms of experience. Possible, and it's by modal. The philosophers call it modal because they're somewhat fancy. And there's some phenomenological terms of art, intentionality, constitution, self-worth, distinction, temporal structure of experience, and so on, and some more. And those are usually relational structures. They have this very relational spirit, and I will revisit that later on. So phenomenology is there are two senses in which phenomenology is about relation. And category theory, I mean, those of you who know a bit about category theory know that relations are very, very important. Very loosely spoken, one could say, okay, it's built about how things or objects relate to other objects, and then trying to systematize those ideas. Okay. Okay, that's now the outline of the rest to follow. I will first talk about some basics of mathematized phenomenology, only some because time is a bit short. Some basics of category theory, I will go very briefly over that. Some of you probably know that much better than me. And then in the main part, I will introduce an entity, which I call the phenomenological category, which is something like an application of category theory to phenomenology. And then specifically look at three questions. What about non-reflective phenomenal properties? It sounds very highbrow. It just means what about these typical features of consciousness that you would think about for like qualia or structures, something like that. B, what is the relation to the observable world? So I said on the first slide, so that you have to think about this relation between a first personal perspective and third personal data. So this point will be about that. And then in the very end, I will talk about what I call higher or reflective phenomenal structure that refers to these things like intentionality, constitution, and so on, which I briefly mentioned on the previous slide. Okay, some basics of mathematized phenomenology. Okay. So I said that one should finesse this preliminary definition of phenomenology, which was phenomenology is the systematic study of first personal experience. And one way to finesse it would be to say phenomenology is the systematic study of how a first person perspective arises from deeper processes within conscious experience. It's quite a mouthful. I will unpack it rather than being just a description of our overt conscious experience. And people are often a bit confused by this. When I say phenomenology, they usually think about descriptive phenomenology, meaning, oh, what's, so to say, present in consciousness at the moment. That's not quite what I mean, actually. I mean something which I call here, for better, for using a fancy term, deep phenomenology, which is about this underlying processes within conscious experience. So as a slogan, deep phenomenology starts with experience, and that should always be our starting point, but it does not terminate in experience. So it's not about characterizing experience, but characterizing everything else. Okay. Now that's the, so to say, the advertisement slide. So you might ask, oh, what do I need this stuff for? I mean, it's complicated stuff, and we'll forget it. And so here I say, okay, it might be interesting. There's two applications which are kind of interesting to many people. One is about neuroscience. Many of you know there are a bunch of models in consciousness science that do not really agree in a sense that they are often about different things. That's the way how it is. Mathematized phenomenology can specify further non-mechanistic constraints on those theories. So it can be used to integrate a bunch of those theories. But for that to work, it needs to be mathematized, because those theories ideally would be mathematical theories, like IIT, for example. So to say, the language of science, of scientific theories, is mathematics. So if one phenomenologists want to make contact with those theories, then they should be mathematized. Now, the second application, now it's very fancy to talk about AI consciousness. Everyone is doing that. So also here, mathematized phenomenology could be very interesting. The way how people mostly work in AI consciousness is saying, oh, you have this computation, you have that computation. If the system realizes this computation, then it will be conscious, otherwise not. Well, okay, that's kind of 1960s thinking, I guess. okay, how could phenomenology make a difference here? Phenomenology is really about finding out what it means to, when and how the first person perspective actually arises in a system. So if you believe that this question of artificial consciousness boils down to the question whether you could have a first person perspective in a machine, then mathematical phenomenology might be a very interesting approach to look at. Okay, so here's just a brief overview of some works in mathematized phenomenology or related. Some of you might remember or know at the end of the 90s, early 2000s, there was work in so-called naturalized phenomenology by Francisco Varela and co-workers. They also did some work on very general formal studies in phenomenology, something like a precursor to what I'm mainly interested in. There's early work by Jeff Yoshimi, it's a phenomenologist from the US. And there are different kind of approaches, like predictive processing is very fancy nowadays. A lot of people are kind of working on predictive processing type of mathematized phenomenology. Some of them, some of that involves the free energy principle, some doesn't. There's lots of work, and I guess most of the people who are here are most interested in that, about category theory. So you will recognize many of the names who are also here at the meeting. So very good. Now there's some related projects which are not specifically about phenomenology, but which I think are kind of related. So there's talk about Qualia spaces. There's this idea of having something like structuralist, relationalist approach in consciousness science. There's a whole bunch of work on integrated information theory. Recently, there's this notion of objective phenomenology, which goes back to a remark by Thomas Nagel and his famous What It's Like to Be a Bad article. And there's conscious agent theory by Donald Hoffman, which I will also talk a little bit about today. Now, you see there is a bunch of activity, but it's like it's not very unified. So people are working on it in their isolated, more or less isolated centers. And the question is whether there's a unifying framework for that. Well, obviously, I think yes. And I would say category theory might be a very good candidate for that because it's very general. So it might have the resources to unify a bunch of different approaches, and maybe some of that can be seen throughout my talk. Okay, now that's it for phenomenology for the moment. Some basics of category theory. I will go quickly over this. I mean, it's probably better to just open a book and read the basic definitions, or ask a mathematician. There are many mathematicians here who know more about stuff than me. What's the basic definition of a category? A collection of objects, and then you pick out two objects, and for these two objects you have a collection of morphisms which satisfy certain properties or requirements about composition mainly and identity laws. I don't go into the details, they're not really difficult actually. Some examples, the typical examples which are always mentioned in the mathematical literature is the category of sets. The objects are sets, and the morphisms between those sets are functions. Maybe something for terminology forget. I don't know how many philosophers are in the audience, so only philosophers might get the joke. But anyway, so Aristotle, he's a culprit. He kind of originated this term of substance, which we want to get rid of. And well, another term or another concept which was invented by Aristotle is that hylomorphism, which is the idea of form and matter. And in category theory, you often talk about eros, but another name for eros is morphisms. And that's why I like to, a philosopher, I like to make a pun on Aristotle, and that's why I call it morphism. Okay. So typically examples, probably only philosophers got. Anyway, so example, category of sets, category of topological spaces, where the objects are topological spaces and the morphisms are continuous maps between those spaces. A very simple example, which I like to mention at this point because it's related to what Husserl did, or to the way how Husserl thought about many things, is that of a group. A group can be represented as a category with one object, where morphism in the category stands for an element in the group. We have here a picture of a symmetric group S3. Mathematicians would tell you isomorphic to the group of an equilateral triangle. So you can rotate it, or you can make reflection symmetries, and that leaves the triangle invariant. And that's basically how Husserl thought about this. He said, okay, that's what we have to do with experience. We have to think about, well, what are the operations to perform such that experiences stay invariant? And if we find out that, then we can classify experience. So what Husserl thought, in some sense, would be to say like, oh, I want to become the group theorist of experience. That's Husserl's approach in the mathematical language. So that's why I chose that example. Of course, you can take then the category of groups, where the elements are different groups, and you think about group homomorphisms. I don't want to talk about these mathematical entities today. I will talk about what I call the phenomenological category. Okay, so the next notion, which you typically, if you open a textbook on category theory, and then you have like a standard progression, and the second thing, first is the basic definition of a category, and the second one is the basic definition of a functor. A functor can be described as a mapping between two different categories, where objects are mapped to objects and morphisms are mapped to morphisms, and some, roughly speaking, categorical structure is preserved. The associativity of composition and the unit laws are kind of preserved by functors. And a typical example in mathematics, which is often given as a functor from topological, from top, the category of topological spaces to the category of groups. And there's a very nice proof which involves to associate any topological space to its so-called fundamental group, and then look at the morphisms for the possible or not possible morphisms on the level of groups, and infer some nice features about topological spaces. Okay. So, and I will often talk about functors, and that's why I have this slide in functors. There are many, 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 many more notions, which I won't go into detail about. It's obviously it's very important, but it's not the time and place to talk about this. I think yesterday you already heard a bit about natural transformations, transformations between functors, the various notions of equivalence in category theory. That's a very nice feature of category theory. I mean, just normally we're kind of used to say, oh, something is identical to something else, and say, no, category theory. Say, no, that's not the right thing to think about it. There are different ways of how those two things might be related. The very strong one is isomorphism, but that's much too strong for many applications. So there are different weaker forms of equivalence, which involves those natural transformations, for example. Maybe I will talk about some of this. There's this notion of a co-limit, a universal object. I just saw the talk by Stephen. I think it was your talk where co-limits were very important to understand IIT or the axioms of IIT. There's also other work in consciousness science where co-limits can prominently figure. The notion of an adjunction, you also heard it yesterday. I will talk briefly about it today, a way to relate different kind of categories actually. Monoidal categories often are very important if you think about compositions of categories or different ways of composing categories. Infinity categories, if you think, okay, you have morphisms, and then you have mappings between morphisms, and you have natural transformations, but maybe you can generalize this whole idea, go to so-called higher category theory, and then the highest which you can go is infinity, 1, 2, 3, and so on, and then at infinity, and there's some special things to do there as well, which is way above my pay grade, but anyway, I think it's very interesting to think about these things in the context of phenomenology as well. Okay, so that's it for the basics of category theory, the notion of what is a category, what is a functor between two categories, and then various higher notions which you typically encounter if you read the textbook here. Okay, So how to construct the phenomenological category? I'm coming to the main part, so to say, of what I will talk about today. So I repeat, phenomenology is the systematic study of how a first-person perspective arises from deeper processes within conscious experience. Was my finesse definition of how to understand phenomenology, which is followed by an hypothesis. And the hypothesis is this can be precisely described by mathematics. Well, kind of mathematics. At least today, I'm a bit biased to thinking about category theory here. Now, there's an obvious question. You often get this question because people are kind of skeptical about this whole idea of using mathematics to think about phenomenology. And they say, well, what kind of mathematics? What are you actually talking about? And there are different, well, 4 different, probably there are more approaches to selecting a kind of mathematics which does the job or which fits phenomenology. The first approach is ultra-liberal. Just say anything goes, so to say. Whatever mathematical structure does the job is a good structure. I don't care about anything else. It's just fine. A lot of people are actually doing it this way. And there is something to it. It seems a bit unsatisfactory to say, oh, well, okay, why? I don't know, it just works, okay? But most people are actually doing it. The second option is to shoot for something which Husserl, which one might call essentialism. So I told you about Husserl and about this kind of grouply flavored method which he advocated. Husserl method of choice, he calls it the variation in imagination. What that means is you have a conscious experience, and then in your imagination you vary it along certain dimensions. So, for example, you hear a melody, and then you say, okay, I can change the pitch, I can, I don't know, change some timings or whatever, but I still have more or less, basically I can recognize it as the same melody, or at least as a temporal object in some sense. But there are basic things where you cannot change, where if you change it, then you kind of make a change to your experience. You can say, okay, now it's a different experience, and that means that signals you that you kind of left, so to say, your group. So Husserl thought a lot about temporal structure, and he said, okay, there's a certain temporal structure which is underlying all temporal objects, motions, melodies, and so on. And that's really something which is very peculiar about any conscious experience of a certain kind. Okay. And so if you follow this essentialist method, you would say, okay, that kind of dictates you a certain, or that prescribes you a certain mathematical approach, and which has this group flavor. Okay, another answer to this question, what kind of mathematics? And was given by my colleague Jeff Fushimi. Phenomenological grounding, it's just a fancy word for saying, okay, being adequate to phenomenology or to mathematize phenomenology, and through authenticity. So not any mathematical calculus will do, but only those where we have some authentic understanding of how they apply. So what's often happening, for example, in science, you start by mathematizing some empirical stuff, and then you are doing some fancy mathematical tricks, and no one really knows how it works except some mathematicians. And then you get a result, and you kind of say, oh, and now you have a prediction on the empirical domain. But if you think authenticity is really important, then that shouldn't be the case. If you want to have an authentic understanding of the mathematics which you apply, then you should be able to kind of link every step that you use to some phenomenological process. So that sounds very reasonable, but of course there's a big problem with that. Namely, what's authentic to me might be very inauthentic to you, or the other way around. Also in one's life, if one learns a bit, then suddenly something becomes authentic, which wasn't authentic before. So there are various problems with that. So a fourth way of answering this question goes back to a remark by Husserl. he said, oh, phenomenological analysis have to resolve back into consciousness. The question is, oh, what the hell do I mean? And Husserl is always very complicated in his writings. So in that case, one would say, okay, one should choose a method of mathematics, or one choose a kind of mathematics which allows one, in the end, to resolve something back into consciousness, meaning being able to make new experiences, to get new experiences. So we heard yesterday, for example, we had this nice thought experiment about Newtonian experiences. That would be a good example of how to resolve back into consciousness in Husserl's lingo. Okay. Please.
Sorry, just a clarification to be sure I'm following. Where would you put IIT in this taxonomy?
Well, I guess I would put it somewhere between 1 and 2.
Okay, okay.
Okay.
Okay, thank you very much.
We can discuss later why. Yeah, I would say that. Okay. But I will talk about IIT on the very next slide. Actually, it's good. But actually not in this respect, but in some other respect. So IIT, and there are some approaches in the literature in consciousness studies which are actually advocating something like a phenomenology-first approach. Not many do that, but there are some notable, so to say, notable examples. And since I want to kind of, I want to state those notable examples, so just for you to see, okay, it's not kind of, I haven't thought that on my own, so to say. And one example that was pertains to your question is IIT, which starts with phenomenological axioms, and at least according to IIT, that is an example of essentialism in the sense that they try to pick out some essential properties of consciousness. It's not so much about the mathematical method per se. They don't really say why it's essential to use conditional probabilities and blah, 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 blah. But they pick out some essential axioms or statements. Another theory, which I'm kind of fond of, it was developed by Donald Hoffman a few years ago, conscious agent theory. And it's a very interesting theory because it's normally presented as a kind of idealist approach. So you only have conscious experiences and actions and everything you get, so to say, by combining experiences and actions. It's very interesting. And if you're not so happy with the idealism, you can say, okay, all the properties of consciousness can be gotten or can be recovered from experience. Okay, so those are the two theories which I think try to start with consciousness, which try to do something like a phenomenology-first approach. And what I'm interested in is what I already introduced as the phenomenological category, where on the next, next slide, you will see the objects are first-person experiences, and you think about various relations between those experiences. It's a very open definition, which is actually open by purpose. I don't know whether there's a technical name for that. There's no fixed interpretation which you give to these things. It's just the objects are experiences, and the edges are relations between experiences. Here for illustration, I just give you a graph. The graph and the category are not the same thing, but they're related. There's technical discussion how they are related. Not every graph is a category, but to every graph you can associate a category. So yeah. Anyway, so what you see here is called an underlying graph of a category, but it leaves out the compositions between arrows. It has the identities here. I think that's very important in category theory, but not the compositions.
Just to clarify the meaning of experience here, you are intending the phenomenological category as, in a sense, trans-experiential, so across different experiences, and a single node is a single experience in its own compositionality, if you want. So just one single experience.
Yes, it's one single experience. I will a bit later talk about like structures or parts of experiences. I think parts supervene on total experience or networks between experiences. It's kind of the other way around how people normally think. You know, you have experience and then you have parts and you relate those parts. Exactly. And I think you have experience and you relate experience and then you get the parts. Okay, I will come to that later. Okay, but before we come to that, actually, just a few remarks. So if you write a paper on category theory and phenomenology, what typically happens, it will be sent out to review if you're lucky. And then you have one reviewer, which is nasty, and a reviewer two, and he gives you the comment, what is all the fuss about? Why do you do it? Formal methods and experience, that doesn't go together. Forget it, it's crap. So if he's a bit more sophisticated, reviewer two is often not so sophisticated. Anyway, there are certain questions which you might ask, some skeptical questions, which pertain to problems of axiomatization more generally. You use axiomatic systems in consciousness studies. So that's the non-funny part here. And the first question is, how does it actually account for consciousness? I mean, we know some things about consciousness and formal structures, they don't look like consciousness. So why are they telling us anything about consciousness? So you see here a picture, a famous thought experiment in the philosophy of AI, actually by John Searle, the Chinese room argument. It works like this. So you have an operator in the room and he gets symbols written in Chinese and he has a rule book, and based on the input he gets, the symbols he gets, he's able to use the rule book to produce good outputs. And the argument of the Chinese room argument was obviously the operator in the room doesn't understand anything in Chinese. So why should we assume that this whole input-output structures kind of create consciousness? And the larger message would be, okay, you have a syntactical structure, but it's not obvious that any semantical component is actually associated with that. Some of you might know I'm teaching in China. I don't speak any Chinese, but I have an app which translates me. So I'm running around and someone tells me something and I translate it. And I'm, okay. And then I select an answer or give an answer in German. And then I retranslate it. And then sometimes it works. So communication is kind of established by that. But I don't feel that I understand Chinese any more than I did like 4 months ago. No way. And as I said, the larger question is, well, are you not doing something very similar, just a bit more abstract? Okay, the second question, I already stressed it a couple of times, how to relate what you are doing or what one is doing with this phenomenological category to something like the observable world. And the third question, how to demonstrate higher phenomenal structures. So we're interested in something like selves and intentionality and all these kind of things. How are they represented in what you're doing? Okay, so that's, so to say, the basic problem of axiomatization. Now there's a second problem, and that goes back to a very well-known thought experiment in philosophy by René Descartes in his Meditations, which has to do with this epistemological status of the outside world. Now, Descartes had this method of like systematic doubt, and he came to the conclusion, oh, cogito ergo sum, I think, therefore I am. I can doubt everything, but I cannot doubt my own existence. So there must be something, some kind of anchor to it all, and that has to do with experience. But the same is unfortunately not true regarding any kind of knowledge that I have about the outside world, that I could have about the outside world. And Descartes had a kind of interesting solution to it. He said something, oh, there exists a benevolent God, and he certainly doesn't want to delude me. So obviously, whenever I see something clearly and distinctly, so after I have subjected it to this method of skepticism, of doubt, systematic doubt, if I then still think it's clear and distinct and it's true, then it is true because there's God and God is nice. And Descartes, like many philosophers after him, he also obviously gave proofs of the argument, gave a proof for the existence of such a being. The first philosopher who basically said, okay, all your proofs of God, so to say, they are kind of strange stuff, or they're BS, or Immanuel Kant. But it took some time in order to kind of seep in, I guess. Nowadays, we're not very satisfied when someone says, oh, I don't know, oh, but there exists God, and he doesn't delude me for some reason. So I can go And that's a problem for formal approaches. If you start with a first-person perspective, a pure first-person perspective, then you might think, okay, how to actually say something about things which are not first-person perspectives. And Descartes' solution was to adhere to God. Nowadays, it's common to have, nowadays we have other strategies. We say, for example, oh, okay, it's the best possible explanation for something. Phenomenologists go into a bit of a different direction. I will come to that in a minute. So that's the second problem. And the third problem has to do with what has been called the observer effect in mathematics. So you see here on the slide 3 people. On the top row, that's Edward Frenkel. He's a contemporary mathematician from UC Berkeley, and well known. He's one of the major proponents of the so-called geometric Langland program, which is, in his own words, a kind of approach to give a grand unified theory of mathematics, and which heavily draws on category theory. I mean, that's much too complicated to talk about the Langland program at this point, but I just wanted to mention him. And he recently wrote an article in which he was thinking about something which he called an observer problem in mathematics. So on the bottom of the slide, there are 2 people. The young one, that's Werner Heisenberg, one of the pioneers of quantum mechanics. And in physics, it's well known that there is something like an observer problem. Physicists don't want to admit it. They kind of try to brush it under the carpet. If you ask them, oh, what is an observer? They would say, stupid question. But still, when you have something like observation or measurement, whatever it is, physics becomes very strange. In some sense, there's a lot of change in what's going on in physics. To spell it out. So it's widely, I would say, it's widely recognized that there is something like a role of an observer in physics. Questions what it exactly means and how to formalize that and so on and so on. But there is this problem which is kind of generally recognized. The same is not true in mathematics. A lot of people think, okay, mathematics, that's the kind of most objective science that we could have. We have statements about triangles, Pythagoras theorem, and I mean, that was true a few thousand years ago. It will be true in 3,000 years. And if Pythagoras didn't found it, then someone else would have done it, because there's just objective proofs in mathematics. But the story is not so easy and so straightforward. And that has to do with some development in the 20th century in the philosophy of mathematics. So it was very fancy, or it was a big project actually around 1900, early 20th century, to look for a finite, small formal system which can produce all of mathematics. There are different approaches to do that. And third person here on the slide, it's Kurt Gödel, an Austrian logician. He kind of said, okay, any formal system which is sufficiently strong is fundamentally incomplete, meaning that it contains truths, or there are true statements which cannot be proven within that system. Proven within that system means derived from its axioms, or from postulates, or from theorems which you already have derived from the axioms. So you cannot do that. I mean, there's a fundamental incompleteness in mathematics. Now there are different ways to interpret that. And some of you might know, who are interested in philosophy or in consciousness studies in mathematics. And there's a long discussion about Roger Penrose's ideas. I'm not going that far. I would say that that's already very speculative, and there are many voices pro and con, whether it's good or not. But there's this interesting observation by Edward Frenkel, who says, well, okay, if it's true, then who is the one who selects the axioms? How to do that? Can it be an axiomatic? Can it be a formal system? No, cannot be a formal system, because then you still have this problem of incompleteness, and you just, so to say, elevated it to a higher level. And so that's a fundamental role of a mathematician in that case, to select certain axiomatic systems or not. How to do that? Well, interest, work, beauty, whatever. There is not. It's hard to. I mean, the jury is out there how to do it, but it's fundamentally an open problem. Now I would like to kind of transfer that metaphor to phenomenological approaches, or mathematized phenomenology, And the corresponding thing or the corresponding idea would be any sufficiently strong systems in mathematized phenomenology cannot account for all possible types of experiences based on a simple set of axioms. And that's really a problem for those people who think, okay, you can give very few axioms and then derive all of conscious experience adequately within that system. So I briefly mentioned Husserl, and I think Husserl, I mean, he knows a lot about mathematics. I'm not sure whether he was aware of Gödel's stuff or still. I don't know when he died exactly, whether he was very old and didn't kind of follow stuff of the time. But I talked a bit about Descartes, about this problem of the outside world, and well, what Descartes did, how quickly did he converge in a certain metaphysical position, which allowed him to make sense of his problems, or make sense both of the fact that we have some indubitable secure knowledge in the subjective, and that we have this problem of the outside world. Edmund Husserl, by contrast, he has very many similarities with Descartes, but there are also some deviations from Descartes, so to say. And what he did, he said, okay, well, let's not jump to metaphysical conclusions at this point and suspend our judgment. In the method, he called it epoché. On the first sight, at first sight, it sounds like giving up. I mean, you have a difficult question. Okay, suspend our judgment on it. Okay, that sounds like giving up. But actually, there was a big payoff for Husserl. And the payoff was that the suspension of judgment enables one, philosophers in that case, to further reflect or explore first personal experience. And that's kind of big payoff here. So that's what he advocated. So let's keep phenomenology sufficiently open to new kind of experiences, new kind of formalizations, construct a category, if you want to construct a category in a way that allows one to retain this fundamental openness. Okay. So at this point, I guess it's good to have a look. So I still have half an hour, right? Okay. Okay, so a brief repetition of what I said today until now. Talked about phenomenology, about category theory, and then about this whole idea of having a formal approach, which is rooted in category theory, to phenomenology, which comes with certain problems, which is not quite straightforward. And a question which automatically arises at this point: why do you do it, and what can you do with it? The final part of the lecture today will be about trying to answer this question: what can you do it? Often I kind of stipulate certain answers. So I hope that some of you who find that interesting might try to work out some of the things which are coming. Okay, so let's start with the most straightforward part, like the non-reflective phenomenal property. I will talk about the concept of supervenience. You see here is a star on supervenience, which means, okay, there is something more, which I should say at this point. And this something more is this: those of you who know, who have some philosophical training, maybe, you know that whenever people, often when people talk about supervenience, they want to talk about metaphysics. Okay, you have mind-matter supervenience, or you have the supervenience between different ontological domains or something like that. I don't mean that. I just mean a very, very kind of reduced to the max, so to say, notion of supervenience, which is very formal. It's just is normally cashed out in terms of function, or subjective function. That. So when I say that some properties are supervenient on other properties, I don't mean to imply that you have something like an ontological jump, which is happening here at this point. It's just a, so to say, a dependence relation or logical relation between different ways of describing a system. That's all which is meant. And with supervenience. Okay, non-reflective phenomenal properties, I just said in the beginning, those are like typical properties that we would associate with consciousness. Qualia, for example. which are supervenient on this mathematical entity, which I was talking about, the phenomenological category. Now, before I will try to spell out how I think about this in terms of this phenomenological category, it's a bit abstract. I want to discuss one example, which was given by Jeff Yoshimi in a book. And he had this idea, well, a good, let's say, unifying interpretation of what phenomenologists are often doing is to say that how certain kind of experiences supervene on other kinds of experiences or over networks or collections of experiences. A very straightforward example, or maybe the prime example that he was discussing, were visual experiences. We have a visual experience of a house, which stands over there. And the idea was, okay, this visual experience of the house over there, it relates to possible kind of sensory impressions or possible perspectives which you could take on the house if you were to move in a certain way around the house. So you stand in front of the house and then you see its front. Maybe you don't know, is it the house or is it the movie set or is it something else? But if you were to move around the house, then you would soon discover, okay, it's real house. So you move with respect to the object that you see, and you have some background knowledge, beliefs, and from that you can derive what you would expect to see. And if you compare your expectations to what you're actually doing, then you have, so to say, a good measure of fit. Does it fit my belief, so to say, or my visual experience or not? And the idea in Jeff Yoshimi's book was to say, okay, you pack all those things together, you construct what he calls a tree set, complicated name, a bunch of perspectives which you could take, given certain kinds of experiences, so it's conditional. And then your visual experience would be supervenient on that. That's the basic idea which you have, which I would think you will have on the phenomenological, on the level of the phenomenological category. Certain properties of experiences are supervenient on this collections or networks of possible experiences which are related to each other. So to spell it out a bit more in detail, so the visual experience of a house over there defines what I call a non-reflective phenomenal property. So for example, a color or a shape or a structure, whatever. Movements, moving from here to there, choosing a certain action corresponds to a morphism within the category. And these possible sensory impressions or perspectives corresponds to the objects in your category, the individual experiences that you might have, or perspectival experiences which you might have. And this notion of supervenience, I said in the beginning, in philosophy of mind, or in more formal approaches in the philosophy of mind, you often find this idea that supervenience can be expressed by a function. I think that it's partly right. One should even go one step further because it's about changes within things and morphisms between things. So the right formal entity would be a functor. And that's the reason why I spent some time on explaining to you what a functor is actually supposed to be. Okay, so maybe best look at an example. Okay. I have two examples even.
No, actually, if you have an example, maybe I'll wait, but just, so what you mean is that the experience of the house is the like made by the different view, or it's more the other way around? So this different views comes from the experience of the house.
What do you mean with made?
Yeah, no, I'm trying to make a sense of this slide as a point, but maybe I can wait for the two examples you said.
Okay, okay. So and the two examples and not mathematical examples. So it's not like one example is the empty set, and the rest is so complicated that you don't understand. Okay. Okay. So the first example is about Qualia, right? So you have here possible experience which you could have, and you have one actual experience, obviously. And it has certain properties, certain phenomenal properties. if you look at all the relations between one actual experience and other possible experiences, that forms the so-called supervenience basis for individual qualia. Okay, if you take 8 and there is a blue qualia here, so to say, or you perceive a blue qualia, that just means that you're in a certain relational network to other possible kinds of experience which you could do. So for example, if you are a kind of early organism who sees something red over there, and the possible experiences would be, okay, I get stomach pain if I eat it, or I feel great if I eat it, I don't know, then you might see it as red because it's ripe. If you see it as green, it's probably not so good. So that's the idea with qualia. And it seems to me there is some like conceptual similarity to a qualia structure approach, in a sense that the individual qualia are just given as relations between, or at least the information about those qualia. Yesterday we had this discussion whether it's relationalism, in what sense, whether it's about knowledge or whether it's about being. Philosophers would say ontological or epistemological, or can of worms, so to say, to open here. But anyway, you have relations between instances of experience, and those relations kind of define what are the individual properties that you have in an individual instance of experience. One thing why I think it's very nice, and it's very nice from the phenomenological perspective, is to say, well, okay, so what about these morphisms, or these which express relations between possible experiences? According to phenomenology, those kind of things constantly change, but they are relative because they are relative to certain things like embodiment or actions, or choices of actions, and certain contextual factors, and so on. So there's a constant change in that. In a good experiment, you would, of course, try to get a situation where things are not changing all the time, because then you have noise and then you cannot do anything with your data, basically. But it captures this phenomenological idea. So you have certain actions like the movement around the house, which might change certain transitions. Okay. The second example, it's a bit counterintuitive in the sense that you think, oh, this quail or qualia are something which is intrinsic to experiences, intrinsic properties to experiences. I think that's intuition which is difficult to have. So the way how we normally think about qualia, or how people normally think about qualia, is to say, okay, what are qualia? Qualia are something like the intrinsic properties of some physical systems when they're complex enough or organized, so I don't know what. And that's really a way of thinking about qualia where I think, okay, let's try to think about qualia a bit differently, because we have been sort of stuck with this first way of thinking about qualia. Okay, so so if you think it's weird with respect to qualia, then the next thing is even weirder. Oh, sorry.
Yeah, actually on this graph, so it came up again, I think a few slides back. So there's like one node that's totally disconnected from the rest. It's self-referential, but here all these experiences, I'm assuming they relate to one conscious agent or body.
So I mean, there's a kind of prosaic explanation. I just put some random algorithm and then it produced some node which have no external connections up. But in principle, it points to actually a very good point. So what you experience is also probably, I mean, that would be an interesting hypothesis, and might also be related to what it's actually not related to. So what are the experiences which you can't reach? If you have a certain experience, you can reach certain other experiences, or you can relate it to certain other experiences, but you can also have experiences which are not available, so to say.
Like if they're not at all connected to anything else, can we even be sure it's the same entity that we're talking about?
Yes, those are two good points, actually. So the first point, what does it mean to have an experience which is not connected to anything else, whether that's impossible? And then, well, okay, I think that's a fair criticism. I think that might be actually not that might be not very meaningful. And the second point, which is implicit in this question, there's a hidden assumption which people normally totally gloss over, but it's very important, namely the identity over time of experiences. That's not clear. If you can individuate one experience, let's say the 0, 1, if you look at it, how it changes after some time, for example, whether it's still the same thing or not. When you use a mathematical formalism, you usually assume that the entities which you write down at one point in time refer to the same thing. There's a certain kind of identity which is preserved across time or across actions. And it's not clear that that's actually the case with respect to experience. But if it's not the case, then it becomes very difficult to think about formal methods, I think. So there's this hidden assumption here. Very difficult to point it out.
Sorry, I'm still unclear about the definition of experience. There have been questions asked. And maybe one way to ask the question for me is, when I look at the graph on the left side, is 0 my experience, my whole conscious experience right now? I'm having an experience as a part of it of the taste of coffee and a visual experience of the slides. And then 1 is my experience at time t+1 that is going to be in 5 seconds. Or is it all one experience where 0 is the taste of coffee, 1 is the visual experience, 3 is the feeling of the back of my, you know, or both, or can it be either? Can you clarify that, please?
Thank you for the question. It's a good question. Actually relates to my second example, but very briefly, I would say it's a complete experience. It's a complete what it's like to be at one particular instance. So the parts of experience, we always believe our experience are parts. We see the, I don't know, we drink the coffee and we see something and whatever else. I wouldn't put that actually into a phenomenological axiomatization at the first level. I would say maybe you get it, but it's not clear that that's actually essential to experience. Yes, each node is a complete experience. Yeah, so each node is a complete possible experience. Not all experiences are actual. So I mean, you always have just one experience usually, except you have something where there's these weird cases where people I don't know how to think about it. But the other experience are the impossible experience which you could make were you to do something.
One question.
Oh, okay.
So I might be wrong, but my understanding of a functor was that it's also a structure preserving mapping. So then if the color space is a category as a relational space, but then over here it's experiences over time or also non-color experiences.
Oh yeah, you could, but you could map it just to one element. It's fine. And you have one element and you have an identity morphism.
Oh, so it's not just it's not between those two. It might be out of the node, something out of the node.
Yes. So oh, sorry, maybe I wasn't specific enough. So you have here one complicated thing, and here you have one. Let's call it a point, or maybe it's not a point. One element in a color space.
Anything except for color is collapsed into something.
Yes, exactly. Yeah. You can that's how you can put it like this. Yeah. So in category 3 example, you often have this case. And when you look at limits or co-cones, you often have like, okay, you have one functor which just goes to one element, and that's it basically. And then you look at transformations between those two things. Okay, and the second that's related to your question, this idea. Well, what about structures? Aren't experiences structures? Isn't that a necessary property of structure? And I would say, well, no, not at first, but at least it's a kind of necessary but supervenient property. And here there's just one structure, which is a very general structure of experience, which is a part-whole structure, Mereology. Philosophers call it Mereology, Mereological structure. And you can quite easily or straightforwardly say, okay, you have all experiences which might relate to each other. Those are the leading E's, and the similarity signs express relations and so on. For that kind of abuse notation. And then you have a part-whole structure or a partial order, and that's another category. And then you look at functors between those two things. And in that case, it's very straightforward to do it. You what I call the CL. I don't go into details here. How to fix it out. You map some elements to P1. You map all the other elements to P2. and you map the different morphisms between them, either to identity morphisms or to this partial order, this morphism which is expressed or which is interpreted as a partial order, and then you can construct a functor. Straightforward thing. Well, straightforward in general. The details are not straightforward. So here you would say, okay, the structure of an experience is supervenient on the relations between experiences and all other possible experiences. So I'm a bit hard pressed if you ask me about fundamentality, because I think that's a very difficult notion. Maybe we have to give it up anyway. So it's the wrong question to ask which property of experience is fundamental and which is not. But that's a further discussion. Maybe we can have it later. Okay, so that's so to say the easy part when it comes to the what I call non-reflective phenomenal properties.
Actually, about the last page. Oh, actually, about the last page, how you understand knowledge there. Why you have the layer of knowledge?
Well, I just wanted to indicate that that's the difference between you say, okay, it's how experiences are, or what experiences are, and what we know about experiences. That's everything which I wanted to say.
So in this sense, then, because you say the experience itself is already related, in the sense that you don't treat it like, for example, Kant's transcendental approach, saying some like whatever you sense that is not yet related. You have like they are already related, and then there's a layer of consciousness try to recapture whatever the relation, but the relation might change, but still in some sense depends on supervenes on the given relation. Is that what you want to say?
I mean, that would be a more sophisticated version, I would say.
Okay.
I mean, if you would say, okay, there's, I mean, those relations expresses just knowledge about relations. There are no relations intrinsically, so to say. There's just knowledge about relations, but those knowledges are relative to a certain constitutional act by your conceptual schemes or whatever. Then you would probably go into that direction.
But why, again, why knowledge? So, I mean, knowledge then is something to do with truth, right?
Okay, well, when I say knowledge here, it's a very deflationary notion of knowledge. It's just what we can say about something. It's not about truth or anything, or about true justified belief or whatever. It's just
I got it. Yeah.
Whatever statement we can do about something.
Okay, thank you.
Okay, so now to have a question about this one again, just to recap. So labeling there in the graph is just labeling. It's not okay. And every node, as you said, it's a whole experience, right? And the transition in the morphisms are like whatever relation you can put between two experiences, right? That's correct.
Yeah.
Okay. And so the functor there would be to in this specific choice of a functor, you associate whatever color could be if applicable, I guess. And okay, so if this is and then this is actually interesting. So qualia would be basically the set of morphisms from one experience to all the others. Is this what you kind of mean?
Well, it would be
because the relations between experiences define a qualia.
I mean, okay. It's technically I would say it's the domain of the functor which picks out which picks something out. But the relations are the domain of the functor which picks out a certain qualia.
Okay. And then my question again: what is intervenience?
Supervenience.
Supervenience. What is supervenience?
Oh, supervenience is just a fancy name for this kind of relations which you have, which I think is actually best captured by a certain kind of functor on this formal level. It's just philosophers call it supervenient. Just a labeling, so to say.
Okay. Thank you.
Well, now that can be.
It's actually continuing along those lines.
Yeah.
I'm wondering if you, but I guess I'm unclear on the nature of the functor that you're writing, because if it's as you said a few moments ago, if the codomain of the functor, where it goes in the color space, is just a category with one object, then it's rather uninformative. And so if you collapse everything down to a single object, think of it as a group or something like that, there's not a whole lot that can then be said about that function. Now, that said, let's hold that saying that maybe you have something a little richer there. And sometimes my experience has been when trying to build functions, you have to think a bit about how to build the right one. It strikes me actually what supervenience ought to be, if you have the right functor on the codomain side, is actually a colimit. You want to pull back some structure that's preserved across that category, across the whole thing, rather than an individual saying supervenience is the entire category. That, again, is not very informative. But if you say, I'm looking for a colimit, some kind of universal structure that then will factor through this, then that actually is saying there's a larger feature that is not apparent from the outset, that then is guiding what sort of knits your experiences together.
Oh yeah, that's a very, thank you very much. Really very helpful. Oh yeah, that's a very, thanks. Okay. Yes.
Hi, if you just advance to the next slide. Could you explain what's going on here?
Oh, I see. Okay, here it's basically just the idea is you have one category, which is this E. It's an old picture, and that's why you have E. It's what I call the phenomenological categories, and you have different relations which are between the objects in that category, and then you have a second category, which is a partial order, which can be interpreted as a partial order, and then you look for functors between those two categories. And one way to construct such a functor would be to, so to say, collapse all the red stuff into one thing and collapse all the blue stuff into one thing, and then make the morphisms right, that identities are preserved and categorical structures preserved, and all these nice, all these nice things which you have to do in category theory. And that defines your functor from phenomenological category to a partial order. So that's an example where you get structure, where you can say, okay, there's a certain sense in which you can talk about structure, which is, so to say, a property of this category in a very hand-wavy-loose way of saying it. 5 minutes, okay. So now I will go quickly through my slides then. Okay, because there's a second point. That was just the first point, and there are 3 points. And the second point is, what is the relation to the observable world? Those of you who are interested in a field which is called applied category, which is roughly defined as an application of category theory, which is very formal and abstract in pure mathematics, to kind of not mathematical stuff, applications to computer science or physics or whatever, they might recognize this notion of functorial semantics. And in some sense that relates to this problem of John Searle and many other people. They have always this problem of, oh, what's the intrinsic semantic component of this formal system? And I think that's the wrong question to ask. We do not, so to say, we do not look for meaning inside of systems, but we should look for meaning outside of systems. There's a projection to observable stuff. So you start with a phenomenological category, and then you build up a functor, or you define a functor to what I call the OPS, which is a category of observable data. And I think that's what's going on. And some examples, there are 3 examples, which I will briefly mention: subjective report, brain states, and the physical world more generally. In each case, I think category theory gives you a good conceptual tool, at least, to think about this relation. Okay, first example, 2.1, the relation to subjective reports. And there's a big confusion in the literature as well. A lot of people think, oh, subjective reports are directly mirroring or somehow conscious experience, and that's not quite correct. So here you see a picture of a German philosopher, Thomas Metzinger, and he used to be very fond of this kind of harsh statements. And he said, like, oh, first-person data, they actually do not exist. They're data, so they're not first-person stuff. In some sense, I mean, it's a bit nitpicky, but I guess he's right. But on the other hand, subjective reports are often treated as the gold standard to inform us about phenomenology. I mean, if I say, oh, it's like to see red, or it's like for me to feel pain, then it would be strange to say, but that's only third personal, you don't really feel pain. So there is something to it anyway. But the question is, how do you get the systematic relation between these reports and experiences of phenomenal experiences? And I also think here, category theory is actually very helpful to think about it. Yesterday, you already heard about the concept of an adjunction. So I think an adjunction, without going into details for time reasons, helps you to make sense of this point. So you have one first personal or the phenomenological category, and then you have a categorical interpretation or a category which you interpreted in terms of subjective reports, and then you look for certain functorial relation between those two categories. Okay, the second example, and that's more closely to what people in IIT do, a way which I think is very good to make sense of IIT or IIT-like approaches, and I took that from Nausberg from a few years ago, is to think about it in terms of transitions between two categories. So in standard IIT, you would have statements, or at least in IIT 3.0. I don't know, we can talk about it later. The relation between what's happening on the level of the information structures which are defined on the neural element, on the neural level, and so to say, phenomenal experience level is just taken to be an identity. I just said, okay, in category theory, identity is maybe the wrong kind of relations to think about, but still you would then say, okay, now then it's an isomorphism, but that's still a very strong relation actually. And in category theory, you can think about other kinds of equivalences which you could have or couldn't have. I'm not going very abstract here, but just for the sake of concreteness, what's not so clear that IIT always gives you that, or necessarily gives you that. The question here, if you have a relation between two kinds of experiences, is it always mirrored in a relation between two file structures of different types, for example? Could be the case that on one level, this one, you have, for example, two morphisms. I mean, category theory, one of the nice things in category theory is that you can have two morphisms between objects, not just one morphism. Why should it be? But is that also mirrored on the other side, so to say? Maybe, maybe not. Another question, are all objects in one-to-one correspondence? Couldn't it be the case that two objects which are sufficiently similar maybe are mapped to the same object in a different category? So those are difficult questions, but it's not clear, at least a priori, it's not clear that a theory like IIT would be able to answer this question. Okay, and the third and last example, and that goes to Immanuel Kant, one of my favorite philosophers. So there's a quote by Kant, which I like to read. It has been generally assumed that tastes, colors, odors, colors, and so on have no proper existence outside of our representation. So Kant was appealing to this idea of secondary and primary qualities of objects, and the secondary qualities like colors, for example, clearly they just exist in our mind or so, but their primary qualities like space, time, extension in space and time, and so on. And Kant said, oh, now if I go farther and for weighty reasons rank as mere appearances, properties such as extension, place, and in general space, no one in the least can deduce the reason of its being inadmissible. Very complicated. What it means, well, primary qualities and secondary qualities are more or less the same. There's no way, no systematic way you can tell me why that shouldn't be the case. And I think in this phenomenological category, it's a way how to make sense of this question. And just say, okay, you have this different, what Kant called primary qualities of objects, and that's just the codomain of the functor, which mapped into, and there was a concrete hypothesis in a paper which I co-authored a while ago, and I think, okay, space-time is just something like an error-correct code for action. I told you some slides ago that there's a fundamental openness, a fundamental role for action, for choice in this way of thinking about things. Well, space and time might be just something like a very general multi-purpose format for keeping track of those things. So it's nothing but a special kind of functor, a special domain of a special kind of functor from this phenomenological category. Okay, so I think with that I stop for now. I would still have this third point, what about higher reflective phenomenal structure, but I spare you that. Maybe we can revisit that later. Okay, maybe I go straight to the questions for the group discussions, because I thought about some questions which you might have, or just maybe you have. Okay, but just before the question, there's this brief summary, and I just left out the very last part, basics of phenomenology, basics of category theory, and then this constructive element. What is a phenomenological category? How can you deal with certain obvious properties of consciousness like qualia, and what its relation to the observable or outside world. Now, possible questions for you. And the first question, why do we need to go all the length here? It's really complicated stuff and it seems to be a bit convoluted. So why do we need to do it? What's the reason for it? And maybe I believe there is a reason of this, but I'm curious to know whether you think there's a good reason. And what actually are the problems that such an approach resolves? There are certain problems in consciousness studies, but what problems do we actually can approach this way? Skeptical question, principal problems for using formal methods more generally for studying consciousness. How universal is this? We had that yesterday in the group discussions. There were often this question, well, but can we extend it to animals, other animals, maybe to AI? I don't know. Is it universal or is it not universal? Is it very specific to human experience? Then the obvious question, what about the heart problem? Philosophers are interested in that question. I will talk about the zombie later. And the last question, it pertains to the very last part, which I didn't talk about. Okay, so thank you very much at this point.
Hi, thank you for the lecture. I'm just wondering, so in the example that you gave with the network of all possible experiences, the nodes were like each moment of experience, so all just like general broad qualia. So I'm just wondering so right now in the empirical research, we have qualia structures for individual modalities. So like qualia structure for color, qualia structure for objects. And I'm just wondering where that comes into play, like where that structure comes into play in the picture with the category of all possible experiences and then collapsing down into the single qualia.
I mean, thank you very much. It's a very good question. And it's a very difficult question for me because I'm a philosopher, and it's basically the question, what is, so to say, the empirical, how does it relate to the empirical situation that we currently have? And that's why it's a very difficult question for me. Well, I'm looking for the picture. Slide maybe.
Well, while you find that, I guess even if we're not talking about empirical, I think I'd be interested to hear what you think about local structures. Yeah.
Well, so I mean, I'm not an experimentalist here, unfortunately, so I can only push it away. So it seems. But I'm not sure actually whether this is right. But what you do when you're looking for qualia structures, you record data about different instances of having experiences, and it's just what this is basically. So that's just what you actually do in a technically, specifically what you do empirically when you record a qualia structure. You record a, so to say, neural activation pattern, for example, if you work with fMRI data or electrophysiology or whatever. And then we'll say, okay, at each time point, you record something that whatever way corresponds to one of these possible objects, and then you look for relations between different objects at different times, which are called possible experiences. They're possible with respect to a certain time, obviously, when you, at one point, you become actual.
Thank you for your talk. Really enjoyed it. My question maybe relates to what we didn't cover with the more higher reflective
structures, but I think I can still ask it. So it's about the validity of introspective phenomenology. So I've read from Francisco Varela in his book, The Embodied Mind, that he argued that introspective phenomenology wasn't disciplined enough. And evidence of that was that different schools of introspective phenomenology came up with different structures. So if we're setting out to mathematize, and I think this especially applies to the more complex reflective structures, how do we avoid wasting time, basically, like going down a rabbit hole, mathematizing a phenomenological structure that isn't actually valid?
So if you read the second edition of The Embodied Mind, there's this foreword by Evan Thompson. And he basically says, oh, almost everything which Varela wrote about phenomenology in the 90s was kind of wrong.
Oh, I have the old version. I haven't read that.
So you should read the new version, actually. But anyway, the point, so that confusion which I mentioned about that a lot of people kind of equated phenomenology just with introspection. But your question is still valid. I mean, you have different methodologies, and how to find out whether one methodology is right. And then we kind of do all this, we go all this length to work with it, but we don't really know how it's right. I think, yes, that's a valid criticism. I don't have a good answer for it. I think that's just science, basically. You try out different ways of working with things, and at one point it works. It produces some interesting results. I think that's what physicists also did. And there's no... Nowadays, we have the big advantage. We can give it to ChatGPT, and we can say, okay, try it out. And come up, let's see whether you can come up with something interesting.
So you said that each node represents the whole experience at the moment. So yeah, I'm working on the time, subjective time. In your structure, I think the time make the time as the months, because each node represents experience at the moment. So we should make the subjective time from the structure, but your structure diagram have the time in advance.
Yes, I think that's a valid point. So how can you, and because especially I also said that, like, if you think about space-time, it's just a nice kind of format of making sense of this. And then what do I mean when I say time here? So I didn't talk about this. That would have been my very last slide in phenomenology. You have a lot of talk about time consciousness. I can go to the slide here. And I think what it just means, it means nothing but having a walk through this graph. You have a graph and then you take a walk, but a special walk, not just any walk. It has to satisfy certain, that's at least the hypothesis. It has to satisfy certain properties, which Husserl called the tripartite structure of time, which is, I think one shouldn't use the word time, one should just say, okay, it's a walk through the graph, but one that respects a certain composition on the level of categories. So you have, basically you start with one category and then you have 3 copies, and two copies are modified according to some principles. Phenomenologists have hypotheses about those principles, but here time just means a certain kind of mapping when you go through this, when you walk through the graph. So I think you just have space-time, so to say, which is an objective notion, but which you only get after something like a functor to some observable thing. So that's why I put time under quotation marks here. I think it's kind of misleading to call that subjective time in a sense, in a descriptive sense. That's the way how our time, when we experience time or when we experience temporal stuff, that relates to this. I mean, it relates to this, but that's identical to this. So you were the one with the memory yesterday, right? Were you the one with the memory? If you had the memory, someone had this memory. It's not him. Okay, no. because that's related somehow. But if it's not you, then which name? Mm-hmm. Yes.
But you didn't mention that. But I think that is extremely important.
Yes, it's very important.
But why you didn't mention it?
Well, because I don't have time to talk about the self.
Because that part is eventually put everything together.
Yes, and I think for that you need higher category theory. So it's really complicated.
So you are kind of
yeah. So some of the which I didn't talk about, like what I call this higher phenomenal structure, has actually to do with what phenomenology is called self and world structures of experiences. And there it's really I think the best way to translate that into this category theoretic language is to actually think about either higher category or think about these universal objects like co-limit, for example, where you can kind of orchestrate all different kinds of morphisms in a very systematic way.
Yeah,